minus 5 0 minus 9 5 1. Okay, this is the A inverse. So now very easily we know that x is equal to A inverse into B. So we will get here x is equal to A inverse into B. We have A inverse, that is 1 by minus 5 minus 1 0 minus 1 5 minus 5 0 minus 9 5 1 into B, and we have given B, that is equal to, here we have B is equal to 3 2 7. So I will put here B is equal to 3 2 and 7. So by again multiplying these two matrices, I will get here minus 1 into 3, that is minus 3 0 and minus 7. So minus 3 minus 7. For the second one, that is 15 minus 10, and for the third one, that is minus 27. Minus 9 into 3, 5 into 2, that is 10, and then plus 7. So after all, I will get 1 by minus 5 into, this is minus 10, this is 5, and this is again that is minus 10. So here if I divide by minus 5, I will get 2 minus 1 2, and this is capital X, that is equal to x, y and z. So we will get x, y, z, that is equal to 2 minus 1 2. So our solution is x is equal to 2, y is equal to minus 1, and z is equal to 2. This is the solution of given system of linear equations, which is given by x is equal to 2, y is equal to minus 1, and z is equal to 2. So this is the end of the third question. Now let us move to the fourth question, which is from the trigonometry sides. So first question of question number 4a, that is prove that, question number 4a. The first question is prove that 2 sine a plus pi by 3, that is equal to sine a plus root 3 cos a. Right, we need to prove that. So let us start with the left hand side, that is 2 sine a plus pi by 3, that is equal to 2. This is sine alpha plus beta. We know that sine alpha plus beta, that is equal to sine alpha into cos beta plus cos alpha into sine beta. So here I will use that formula, that is sine, here that is sine a into cos pi by 3 plus cos a into sine pi by 3. This is the formula, sine alpha into cos beta plus cos alpha into sine beta. Here alpha is equal to a and beta is equal to pi by 3. So this is 2 sine a. Now cos pi by 3, that is cos 60, that is equal to 1 by 2 plus cos a into sine pi by 3, that is sine 60, that is root 3 by 2. If I multiply 2 with this bracket, then I will get here 2 into 1 half, that will be cancelled. So that is sine a. Here 2 again cancel, that will give root 3 into cos a. So this is our right hand side. So we have proved 2 sine a plus pi by 3 is equal to sine a plus root 3 cos a. Right. This is the first one of question 4a. Now for the second question of question 4a, that is prove that sine minus theta into tan pi by 2 plus theta into sine pi plus theta into sec 3 pi by 2 plus theta upon sine 2 pi minus theta cos 3 pi by 2 minus theta into cosec pi minus theta into cot 2 pi minus theta. So we need to prove that this one is equal to 1, right? So first of all we need to clear the idea of unit circle. So we will find the value of all these functions from the unit circle. Here I again draw the unit circle, right? This is all as TC. Here it is 0, this is pi by 2, this is pi, this is 3 pi by 2, and here that is 2 pi. So as we all know, sine minus theta, that is equal to minus sine theta, because that is in the fourth quadrant. So here sine minus theta is equal to minus sine theta. Then tan pi by 2 plus theta. Here pi by 2 plus theta, that is in the second quadrant, and the second quadrant tan will be negative. So pi by 2 plus theta will be in the cot. So our answer will be cot theta. Okay, here tan pi by 2 plus theta, that is equal to cot theta. Okay, again because here the negative, this is second quadrant, so I will get minus cot theta, right? Because in the second quadrant tan will be negative. So our answer is minus cot theta. For the sine pi plus theta, pi plus, that is in the third quadrant. In the third quadrant sine is negative, so our answer will be minus sine theta. Here function will not be changed. In the same way for the fourth function, sec 3 pi by 2 plus theta. Here there is 3 pi by 2 plus theta, that is in the fourth quadrant. In the fourth quadrant cos theta and sec theta is positive, so our answer is positive. And here there is 3 pi by 2, so function will be changed, we will get sec. So here we will get complementary function, that is cosec theta. Okay, so this is the answer of all the functions in the numerator side. Now for the denominator side, in the same way we will get the answers. Okay, so here I will get this one is equal to, I am directly writing the answers of that functions using unit circle. So here I will get minus sine theta into minus cot theta into minus sine theta into cosec theta. This is the answer of all four functions in the numerator side. This is minus sine theta, minus cot theta, minus sine theta, and again cosec theta. In the same way, if we discuss about the denominator side, then we will get here I will get here this is equal to minus sine theta, that is sine 2 pi minus theta, that is equal to minus sine theta, cos 3 pi by 2 minus theta, that will be minus sine theta, again cosec pi minus theta, that is equal to cosec theta, and cot 2 pi minus theta, that is equal to minus cot theta. So here this will be cancelled, so our answer will be 1. This is the right hand side. So we have proved the second one of the question 4th A. In the same way, let us move to the third one. The third question is prove that, here we also need to prove that tan inverse 1 by 2 plus tan inverse 1 by 3 is equal to pi by 4. Here we need to prove that tan inverse 1 by 2 plus tan inverse 1 by 3 is equal to pi by 4. first of all I want to remind all of you the idea of how to get tan inverse alpha plus beta, right? The formula tan inverse alpha plus beta is equal to tan inverse alpha plus beta upon 1 minus alpha into beta, right? So now we have alpha is equal to 1 by 2 and tan inverse alpha, I will write it again. The formula is tan inverse alpha plus tan inverse beta is equal to tan inverse alpha plus beta upon 1 minus alpha into beta. This is our formula. We have in this case alpha is equal to given 1 by 2 and beta is equal to given 1 by 3. So this one is equal to tan inverse 1 by 2 plus 1 by 3 upon 1 minus 1 by 2 into 1 by 3. Okay, so that is clear that this is equal to tan inverse 1 by 2 plus 1 by 3, that is equal to 5 by 6, and again here this one is equal to 1 by 6, 1 minus 1 by 6, 1 minus 1 by 6, that is again 5 by 6. So this is equal to tan inverse 5 by 6 upon 5 by 6, that is equal to tan inverse 1, and we all know that tan inverse 1 is equal to pi by 4, right? So tan inverse 1 is equal to pi by 4. So we have proved that tan inverse 1 by 2 plus here alpha is equal to 1 by 2, so tan inverse 1 by 2 plus tan inverse 1 by 3, that is equal to pi by 4. So we have proved the third question of question number 4a. Now let us move to question number 4b, which is the first one is from the graph. The question shows draw the graph of y is equal to sin x. Draw the graph of y is equal to sin x from minus pi by 2 less than or equal to x less than or equal to pi by 2. So as we all know that here to draw the perfect graph without graph paper is not possible, but still I will show you in which manner we will get the graph of y is equal to sin x. We all know the value of sin minus theta is equal to minus sin theta. So the value of from minus pi by 2 to pi by 2, then our graph will be in this manner. This one is for 0. Okay, here for example this is pi by 2, here for example that is minus pi by 2. For sin pi by 2, that is equal to sin pi by 2, that is 1. For example here is 1, here is minus 1. So sin pi by 2 is equal to 1, sin minus pi by 2 is equal to minus 1, and we all know that graph will be go in this manner. Okay, this is the graph of here, that is for minus pi by 2, this one is for pi by 2. We also know that for sin pi by 6, that is 1/2, that is here, that is for sin pi by 6. Okay, in the same way that is here minus 1/2, this is plus 1/2. Okay, this is equal to minus pi by 6, this is equal to pi by 6. So in this way we will get the graph of sin x for minus pi by 2 less than or equal to x less than or equal to pi by 2. So this is the graph of y is equal to sin x. Okay, let us move to the second question, in which we need to prove that the question second is prove that cos 3a plus cos 5a 2 cos 5a plus cos 7a upon sin 3a plus 2 sin 5a plus sin 7a is equal to cot phi a. So here this one what we need to prove. Okay, we need to prove this one, cot 3a plus 2 cos 3a plus 2 cos phi a plus cos 7a upon sin 3a plus 2 sin phi a plus sin 7a, that is a cot phi a. So here logic is we need our answer in the phi a form. So here I will put the cos phi a in this expression as it is, and I will try to find the solution of cos 3a plus cos 7a, right? So here this one is our left hand side. So left hand side is equal to this one, that is equal to here cos 3a plus cos 7a, here c plus c, that is equal to 2cc, right? So this one is equal to 2 cos c plus c, that is 2cc cos 3a plus 7a upon 2. I will get 3a plus 7a divided by 2 into cos 3a minus 7a divided by 2, and I will put here 2 cos phi a as it is, because I know I want the answer in cos phi a form, right? In the same way, for the denominator, sin 3a plus sin 7a, s plus s, that is 2sc. So I will get 2 sin 3a plus 7a divided by 2 into cos 3a minus 7a divided by 2 plus 2 sin phi a. Okay, so this one will be is equal to 2 cos 7 plus 3, that is phi a 10a by 2, that is phi a, and this one be cos minus 2a by 2, that is cos a, cos 2a, that is right, cos 4a divided by 2, that is cos 2a. Okay, because cos minus theta is equal to cos theta, plus 2 cos phi a as it is. The same way for the denominator, here I will get 2 sin phi a into cos 2a